This is a Packard Bell 98C22 chassis. This is the generation after the test set, which is a 98C18. I'm going to try and make this a backup chassis just in case something major goes wrong with the test set to where I need to put a backup chassis in and take time to diagnose. Yeah, we'll go over the differences. I'm going to blow this off and clean it up. It's pretty grimy. This is a high hour chassis. My idea here is to create just a drop-in backup chassis. That way if something goes wrong with the chassis that's in the Packard Bell test set that's not quick and easy to diagnose, something that takes some time to replace, or if I'm busy and it's not convenient, I just pop this in. Now this is the next model above. So the difference is ours has that thing here, and basically all the color demod and video and stuff is vacuum tube. In this one, almost everything's solid state. It uses dual gate FETs to demodulate the color. It uses a lot more transistors, fully solid state audio. Now this is a high hour chassis. I cleaned it all up this morning with air and a brush, and I just see a ton of stuff that's been replaced on this, like the audio output IC. RCA SK is like NTE. Again, RCA SK. You can see this was replaced in 79. I believe this has been replaced, and you can see the focus pin on this socket. This is high hour. Look at the discoloration of the socket. These two 1 microfarad electrolytics are pretty tired. The flyback has been changed. All the tubes have been changed. This is really a high hour set. On the bottom, the horizontal efficiency coil somehow got broken and it's off to the side. That's not going to hurt anything. Just can't adjust it from here. It's got a broken capacitor on the bottom I need to replace. I think this capacitor got broken it was probably set down on something that wasn't flat. And the same thing with the horizontal efficiency coil. It's not going to hurt anything, but it's just not, yeah. So this I'll probably just leave. Maybe what we'll do is we'll get this started on the jig and look at it and see how it's working, because I got the tuner, I got everything. I checked the electrolytics, the ESR, they're fair. They probably won't be for long, but this has got the Thordarson, yeah, I can do that. This has got the Thordarson flyback. These are the good flybacks, and this looks relatively low hour. Whoever soldered it in looks like they did a nice job, but this is not the original flyback. This looks sort of low hour. It's hard to tell, but this is a high hour set, and it's had a lot of repairs done to it. I'd like to take a look at these FETs, see if I can see if they're original or if they're... Back to our 98C22 spare Packard Bell chassis. Visual inspection showed that, you know, some stuff was broken, like this capacitor here. And I checked a bunch of electrolytics. What I did is I printed out the SAMs, and I went through and checked all of these, verified that I checked all of these with the ESR tester. And I'm going to replace these two 1 microfarads that are on this board. They're just little small ones down here. Two little gray ones, and basically they're for the horizontal blanking. So I'm going to change those because they're up around 40 ohms, but everything else checked out. Some of them, what they call our electrolytics, are these. I'm not exactly sure what this is, if this is a tantalum, but 106 is tin. So that's 10 microfarads at 6 volts. Is that tantalum? Is that what that is? But of course they're good. Or maybe they're shorted, who knows. Alright, I changed those two, and then the blue one that was broken. One of the two of those gray ones is pretty much open, so we're ready to put this thing on the jig and see if it Klinko strinculates. We're setting up the test jig here in the garage where it's nice and dark. So I'm going to get this 98C22, which will be our backup chassis for the Packard Bell. I'll get it connected up to the jig and we'll fire it up and see how it works. I went over everything I could check with it powered off, you know. We'll just have to see if it works. Guess the first thing I'll do is I'll turn the screen controls all the way down, which they were pretty far up for this thing. So let's see, screen, service switch, instant on switch. We don't want that. This is when they started to put instant on in tube sets. I think because solid state was coming up, they had to sort of compete. So oh, we could connect the speaker to here. Where's the speaker? That way we can hear if the audio demod is working or not. So not a lot to these jigs. I mean, these were, oh, I got to do the convergence. But yeah, I mean, basically just yoke, CRT, ground, and high voltage. That's it. These jigs are awesome. Well, it does not look like I have the appropriate adapter. This is the resistor for the convergence, but this is 9-pin. This is 8-pin, and there's an adapter, so I'm going to have to figure this out. Have to open this. I think it's just a resistor, and then we'll have to put that resistor here. It basically goes from the cathode to ground, and yeah, it certainly is nice. I'm going to have to sit down at the computer and do some research. So yeah, this is just a 150 ohm resistor. Let me see what I can come up with. Found something even better, which is an actual convergence assembly. And yeah, it's just between pin 1 and 2. I took some parts off of this, but it's still measuring about 200 ohms. So that's really all you need with the convergence, is just to pull the cathode of the vertical output to ground a little bit, because there won't be enough deflection. So I'm going to just plug this in. This is part of a convergence assembly, at least for Packard Bell. This is a 9-pin. The RCA is an 8-pin. It's the same exact circuit though. It's time to apply power. Got our tuner here. I'm in the garage by the washer and dryer, which is probably a death sentence, but I don't know if this is on and off, so here we go. On or off. And I heard a little pop, but I don't see anything, so which one of these? Wait, maybe it is. No, that must be the instant on. See how those are lighting up very, very dim? Okay, that looks like it. I hear it now. I hear it humming. Oh boy, listen to that. Crap, am I red plating the tube? Shit. Well, that was not something I wanted to do. That's why you could hear it clicking away. So why did we red plate on the horizontal output tube? That's why I always have a meter on the cathode or the plate. And the one time, this is the one frickin' time that I skip doing it, look at what happens. It's a $50 tube too. Well, I don't think I heard it. Crap. All right, I pulled the tube out. Let me turn it back on. And yeah, the light does come on. And let's see if we get any volume. Is this tube here lighting up? Not at all. There it goes. That's the vertical. Nothing, no sound. Yeah, I think I hooked this up right. Just totally quiet. I mean, I did hook it up to the jig here. Wow, this chassis is a little problematic, isn't it? Well, this capacitor is getting hot too. So this sort of proves something, that a high hour set will be more likely to have components, capacitors, fail than a new old stock low hour set, because this chassis is newer than the one in the test set, and the one in the test set got 2,500 hours out of the original set of capacitors. These things are already, that thing would blow up if I left it on. This one's cold, this one's hot. So we got a bunch of problems here. We got a little bit of a basket case, I think. So the first thing I want to do is with the tube out, I want to see if there's a signal from the horizontal oscillator on this tube, because that thing red plated fast. And you just can look at this with a scope, any kind of scope, and I could swear it was, because, and there it is. Let me try and set this up. Can this not handle a signal that big? Maybe not. That might be close to 200 volts. That the peak to peak. Okay, well, I'm a little bit off the scale here, but I also don't have the tube in. But you can see right here, the frequency is at 14.9, and if I adjust the horizontal hold, it changes. So the horizontal oscillator is running, which I'm not surprised. I mean, we heard it screaming. So what's going to cause this to red plate that quick? Well, a shorted flyback, shorted high voltage regulator tube, a shorted damper. I mean, that thing lit up real fast. So if it's not a problem on the input, which is what you always want to check first, which is this, and that's the horizontal oscillator is running and feeding a signal into the tube, then it's something on the output. So, like I said, the flyback in this was a replacement. Yeah, so, you know, right in the middle of extreme alert. What is an extreme alert? So you hit it and it opens up to Twitter, right? What is it? Oh, here we go. A TikTok star went missing. That's what it is. A TikTok star went missing. I am trying to refrain from laughing. Anyway, back to the subject at hand. This looks like a Thordarson flyback, which these, we don't know. But what we can do is we can do a few simple things to diagnose this. So let's try and diagnose this red frying the horizontal output tube. First thing we're going to do is we're going to put a meter right here. Wow, there's a lot of freaking heat coming from there. Really? Damn, is this stuff supposed to be that freaking hot? Jeez. Oh, that's getting ready to blow up. I almost forgot about that. I'm doing real good today. I'm going to get the Silver Star Award. Okay, so this is the cathode. I guess I got to put kind of riding the short bus today. I probably should not be working on this. Just, I guess it's all up for sacrifice, though, isn't it? Isn't that what this is all about? Blow it up and not feel guilty. All right, we should not go over 200 milliamps here. And I might have a bad Chinese clip lead, so stand by. Oh no, there it goes. Oh, that time the high voltage started to come up. Ooh. The high voltage came up a little bit. Holy crap, okay. And you hear the tube squealing. So let's get this out of circuit first. Right? Just for... Ooh. That thing sounds like it's shorted. I don't like to leave this open, but I'm going to try and do it for a second here. That definitely looks like it's the problem, this tube. Boy, did I diagnose that quick? I deserve a freaking gold star if I got that quick. Here's another 3A3. You should never use a 3A3. You should use a 3CU3. I think it is an updated immune to short like this other one probably did. But let's try this. I don't know if it's any good. All right, here we go. And this is precisely why I have the cathode current fuse in the other set. To protect against this exact thing. Well, that one... Boy, look at the scope picking that. I'm sure that scope loves sitting next to that high voltage lead right there. That's another award winner. But yeah, that was the problem. Shorted 3AU3, or it went to air. Because you see how it's right on my mark there. Does it have... Oh, it has a getter. It looks like it's gone white. Look at that. The getter is at the bottom. It looks like it's gone to air. This tube has gone to air. That was the problem. That's what was causing the horizontal output to red plate. Okay, let's get back to, let me clean this up and we'll get back to where we were. All right, here we go. I'm going to black that out so it's nice and dark in here. I got the CRT hooked back up. I unplugged it when we were screwing around. And yes, the capacitor is still getting hot. I'm hoping that will reform. Let me go into service mode here. And then I'll bring the screens up one at a time. Well, that's an interesting looking. Oh, there we go. Why is it light on the dark in the middle and light on the outsides? There's blue. Why is blue all the way up? And red doesn't do anything. Okay, there's brightness. Vertical looks like it's way off, and there's no red. Let me play with the CRT socket here and see if I can get red. Figure out why there's no red. Well, that is a very weird looking raster, I will say. And I think this thing does raster, doesn't it? Come on, focus. You don't want to focus, huh? There you go. They're very odd looking. That could be a lot of filter hum, maybe. All right, there we go. That's what I was looking for. All of a sudden, it just woke up. I moved something here and it just woke up. But it's weird how it's red in the middle. I don't know. Maybe this needs to be degaussed. Probably time to put a generator on it and see what we get. Start off with window circle here. It looks like the horizontal frequency is way off. So we can bring that in. There we go. Where the hell is red? It looks like the vertical's rolling. Where is red? Okay, there's vertical. Brightness. That looks like sharpness or video peaking. I don't know what these are. They're not doing anything. Color bars. We have no color demodulation. Yeah, there's a lot wrong with this thing. Absolutely no color, no tint. This has got several integrated circuits in it, which could very quite possibly be a problem. Let's take a look at the bandwidth here. Bandwidth looks really good. The IF bandwidth, it's should have 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, you got all 7 there. So the bandwidth looks good. Of course, we can't see the chroma bandwidth because this gives you the chroma bandwidth because the color demod is not working. The rest of it looks really good. Except there's no red. It's like, let me play. I've been tweaking on the fine tuning, and this is an automatic fine tuning. And I cannot get the color to come in. So I'm going to try tweaking the color killer, which is right here. So that's right here. And of course that does nothing. Crap. So color killer, what else do we have here? I don't think anything else that would disable the color like this. Oh, we do have a CRT bias on this. So where is that set? Oh, that's set all the way down. No wonder why I got the screens. I was thinking, oh, my CRT is weak, but no, it's just like the later RCAs, this has a CRT bias and it's set all the way down. Okay, good. So the speaker in here is working. So we got audio problems with this set. We got audio problems with this set. We got no color, and it uses an integrated circuit in the color. So we got audio problems. We got no color. And it looks like we got no red drive, maybe? Because there's, yeah. If I go to video, and I'm on a crosshatch here, and this is the green screen. This is the blue screen. And this is the red screen. No, sorry. This is the red screen. You can see there's no video there. So what's going on with that? That almost seems like the cathode is open. God, I hope it didn't hurt my jig. Well, it seems like the jig has developed leakage between the heater and the red cathode, which really, really sucks. Well, I don't know. I took the jig apart and pounded on the CRT neck and nothing. So that really bums me out because I put a lot into trying to get this jig together. I don't know if this is just a regular 19-inch tube or what kind of tube this is, but I don't even know if it matters. You know, it's not like we're going to be watching TV on it. We just need to see if the color demodulation works. So we have an idea here what's not working. The color demodulation is not working. The sound is not working. So I think that's where we need to go next. The capacitor has cooled off. It's reformed. It's cooled off. I did check. The heater does have the 180 volt potential on it. So I don't think this thing caused the CRT to fail. But that really bums me out that the jig is dead now. So this set uses the try and say that again. This set uses a integrated circuit for the 3.58 megahertz color oscillator. I was thinking put a scope on this, but why don't I just get the SDR radio and put it on 3.58? Have a listen and we'll see if this thing is spewing out any oscillation. I'm real bummed about this. I don't know if it was like that, but you know, it still tests great emissions. It's just got a heater to cathode short, so that's a real bummer to me. And maybe put some inductors in the heater line to isolate the AC off. I don't know. because all the cathodes in these things are driven with all the cathodes are driven with the video signal, the black and white video signal. They're basically all paralleled minus the drive controls here. It has its own winding, and it has a 180 volt bias on the filaments to keep the potential between the cathode tube and the filament heater from shorting together. Well, it shorted together, so I gotta think about this, but maybe a couple inductors. I don't know. All right. Get rid of this. That didn't help, did it? 3.58 megahertz. Let's see, what type of modulation? Does it really matter? We could do narrow FM. There's nothing there. Right there's the chip. See, there's the crystal. Nah, there ain't nothing there. Nothing at all. We'll go try this on the other TV. So on this, all you have to do is get near it and you can see it there. Well, you can see every harmonic of it. Yeah, here there's nothing. That chip is going to be bad. And probably that audio chip too. You have 341 volts on the collector of the audio output transistor. That seems a bit high. So it gets its bias from the IC right here. So if the IC is bad, it's not going to bias the transistor on. It's not going to conduct. We should check the emitter. Between emitter and base should be about 600 millivolts. Wow, 384 volts. That's insanely high. Why is that so high? That shouldn't be that high. There's no way that should be that high. That rail is only at 270 volts. Even if there was no load on it, the highest it would be 270 volts, right? Because you have two resistors here, and then you should have 270 volts there, and if that was the only thing, no wonder why that capacitor was getting hot. Holy crap. Huh, wonder what's going on there. Maybe that lack of load is the lack of load of the audio output is causing all this to be over way too high. That's why the capacitor was getting hot. So there's some voltage checks on the audio output here. So the collector is 343 volts. This is either the base or the emitter. I don't know which one. Doesn't really matter. But it's at 0, which is no surprise, and this is the other one, which is either the base or the emitter, and it's at 0. So just as I suspected, the integrated circuit is not biasing the chip. Crap. That's not an easy integrated circuit to get. I could not find that in NTE. Only RCA SK, and I could not find it. So this might be a DOA adventure. This is one reason why I prefer vacuum tube stuff, because these old early integrated circuits are all going bad, I think just from age, and they're really hard to get. I'll have to do some research and see what I can find, but the odds are the ones I get might be bad too, so it's pretty bummerish. Maybe there's a common voltage that feeds both of those ICs that's missing. I could check that. Okay, so there's, on the audio output, there's 16 volts, 16, flag 5, 16 volts. On the 3.58 megahertz oscillator, there's also flag 5. Where does this come from? A shorted Zener diode, probably? Alright, so I am probing every single pin on this IC. This is the audio output. 006, 000, 000, 000. There's nothing here on any of these pins. So I bet you that 16 volts is missing. That's why we don't have nothing on the sound and nothing on the color. Huh. Where does that come from? Well, that comes off that winding of the transformer. Through a 100 ohm 2 watt resistor to a 1000 microfarad capacitor. Is that the one I replaced right there? And then that's flag 5. So is that 1000 microfarad capacitor right there that I replaced? The one that was broken? Let's see if we have anything across it. 17 volts. And why the hell don't we have anything on the audio output IC? What's going on here? All right, well, that voltage is not even getting to the 470 ohm that feeds that audio IC. I don't know what's going on there. All right, well, I get, yeah. Don't ever trust the SAMs 100%. So see how we have the 16 volts coming in here through a 470 ohm. Then we have this filter capacitor, then it goes into the audio IC. Well, there's 0 volts on that pin of that audio. There's 0 volts here. So I was looking for a 470 ohm resistor. I was looking at the wrong resistor. So I found this one, R212, which is really a 220 ohm. I can zoom in on it here. See there, and I'm connected to it. See the big white capacitor that the ESR checked good on? Well, we have, on that side of that resistor, we have 0.46. On this side, we have 17.4. What do you want to bet that is shorted, that capacitor? What's more likely, the capacitor is shorted or the IC is shorted? And both of these ICs do share that 16.5 volt, but this one has it. I checked this one. It is getting the voltage. Let me get this out of here. I would almost bet money that this is short. It could be the IC, but I'm leaning towards that. That's where checking ESR can be deceiving. You know, you check them with an ESR meter. Oh, it's good. It's, 1 ohm. Well, yeah, it's a 1 ohm resistor, not a 1 ohm ESR capacitor. Yep, this thing is dead shorted. On diode check, dead shorted. All right, let's see. There's a chance we have audio now. Yep. Yep. Very, very low audio. Oh. Very quiet, if anything. I would expect that to be very loud. Huh. Let's check the voltage on our audio output IC. $139 volts, that's pretty good, but where's the... Maybe because that capacitor is missing? Maybe it needs that capacitor to force the audio. The audio is just being all bled off through the positive. Because that's very weak. Very weak sound. See if adding a few microfarads here helps. Nope, no effect at all. Huh, wonder why it's so quiet. You know, I know that speaker is not the best and it's down inside there, but I would still expect blaringly loud. Yeah, well, I hooked another speaker up and I would certainly expect a lot more. I mean, yeah, I would expect this to be blaringly loud. That should put out a couple watts. Try twisting the thingies, maybe. I don't know, I would expect it to be very loud. And it's not very loud. Is there a volume limiter on this thing somewhere? I don't think so. Wow, they are driving some current through that transistor. Wow, that thing is hot. This capacitor is getting toasty again, too. Not like it was, though. It's a lot better. Well, I have it hooked up to the converter box, and the audio is just a whisper. Listen. It has a pretty sharp picture. You can see the bad shorted cathode, heater to cathode. If I turn the blue screen down, I turn the green screen down, look at what the red video looks like. Now if I turn red down, look at what green looks like, look at what blue looks like, and then I'll go back to red. You can see there really just is nothing there, because all the video information is being pulled into the power transformer. That's kind of sad, but maybe it's been like this the whole time and I just never noticed it because I was using it outside. But yeah, I mean, with color information, because the color information comes in on the grid, it might actually look okay. I don't know. I mean, it's still usable to diagnose for sure, but kind of bums me out. So yeah, the audio is very weak, and there are no other electrolytic capacitors in that circuit, I'm pretty sure. And the color oscillator is not running. So we'll continue with this. I'll try and get those two ICs. I was looking closer at the high voltage rectifier tube. See the cracks in it? Right here. See, it's cracked. It's gone to air. And that would have fried that horizontal output tube so fast. You know, we can look back at the video and see how long it red plated for, but it was hard and hardened quick. It would have melted down in a matter of 2 minutes. It would have had a hole blown in the side of it. It was on its way to cremation that quick. Bad rectifier tube. All right, I found the SK catalog, which is the RCA version of NTE online, and I'm figuring this IC out. So 99S042 is the audio IC, so I put that in the search bar down here, and what I've done is I've gone through and I've reversed, which is actually an NTE or ECG 710, but they don't, NTE doesn't seem to support it, but ECG does. So I'm finding it. It's also an LA 1342. So I'm going to find it. I also reverse figured out the 99S022, which is the color oscillator, which is just a RF-IF amp. I guess they're using it in feedback or something. But you come over here to the parts list. Here are the two ICs. And like I said, the audio is not listed in NTE, but yet I guess NTE dropped it when they took over ECG. So these parts are all available. You just have to really like sit down and start doing research. But yeah, I found this one, which was also a UA 703. So I got some of those on the way, and I got the ECG 703 on the way. Or I'm sorry, the 710, the audio IC. We gotta fix this thing. I dug the actual information out that comes with the TV, and it has a schematic and parts list. So this is the factory schematic here. And the first thing I did is I measured all the voltages that are on this integrated circuit, which is the chroma oscillator. And all of them are 19 volts. Pin 3, pin 5, which are supposed to be 1.4, are 19 volts. Pin 1 and 7 are 19 volts. The only one that's 0 is 4. So that chip is completely bad. It's completely not conducting. And that should be about right, because probably when it starts pulling current through that 560 ohm, it will drop to 11 volts. Then I measured all the voltages that are on the audio output IC or the audio drive. God, this is shaky. There we go. The audio driver IC, and they're all spot on. Well, they're all 200 millivolts low, but they're all spot on, all of them. So I don't know. I'm kind of thinking maybe there's another problem here, but here, this one, where is it? This one is definitely a bad IC. It's ordered. It's on the way. The other thing I did is I took these two dual gate FETs out, and I tested them in my little M tester. I just tested them with one gate at a time, and they seem good. So that's good, because these are all these parts are very expensive. Every one of these parts is like between 10 and 15 bucks in this thing. That's why I like vacuum tubes, man. If you're going to do a tube set, screw the hybrid stuff. Go full vacuum. I also feel that this needs some thermal grease under it. The transistor feels quite a bit hotter than the heat sink, and you don't see any thermal grease there. So yeah, all voltages on, and this is that chip right here. Let's see how close we can zoom in on this thing. This is that oscillator chip, which is an IF amplifier. That guy is bad. I see some green corrosion there. That thing is bad. Guaranteed bad. Have a diode there. Here's our SK. There's our bad tube. We're going to fix this thing. We're going to make it clinko-twinkulate again in stereo. Full color stereo. Just as I suspected, no thermal zinc grease on the audio output. We'll take care of that. I got the good Dow Corning stuff here. Silicone heatsink compound. It's just zinc grease. Wow, look at the dust on the NTE ECG 710. Look at that. But we got the 703 here, which is the color oscillator, and we got the 710 audio IC. Here's the oscillator right here, which there's one in a metal can. I don't like these early epoxy dome things. They always seem to be bad. So I found one in a metal can, a Fairchild one, so that's on the way. I got a 270 microfarad cap to replace that one that was shorted. And this is epic. The amount of dust that's on this is just insane. And this is the audio demod IC. TAIWAN. For a limited time only while supplies last. Going fast. Also, I got this header. I hope this works. I want to make a IC socket for this. Just take these pins out. These pins are like, yeah. Okay, I got our socket pins in here. If I can zoom in on that a little bit for you. That's for this IC. Let's talk about this IC for a second. This is, and I recognize this because I remember changing this in early receivers, like hi-fi receivers. So I had to send Jordan Peer and ask him, you know, what exactly did this IC go in? And so this is the info I got from him. Now keep in mind this was yeah, so this is what this was really used in, as an IF amplifier for the tuner section in these receivers. Late 60s to early 70s, Sherwood, Pioneer, Sansui, and sometimes Kenwood, most commonly in the Sansui 2000A/X, 4000 and 5000. Next would be the Pioneer SX1000 series. I think eventually they were used in some JVC stuff too. They go bad a lot. Normally supposed to double the IF in each stage until you get to the limiter. So yeah, these are very common to go bad. I don't know why Packard Bell is using it as a colored oscillator, but they are. So don't question your engineers. Replace the capacitor there that was shorted. Still not sure about the audio output IC yet. I might take some time and check some of the other stuff like the volume control. Just make sure that everything else looks good. Because like I said, all the voltages on that were dead on. This they were not. This is a Fairchild part. Interesting, it's got a date code of 1970 on it. I thought the set was like a 69. So was this replaced? I don't think so. So that sort of dates the set around 1970. All right, the new chip is plugged in there. We're on 3.58. Let's see if we get a signal now. Oh yeah. Look at that. Nice and hot. Look at that. I think I may have figured out why the volume is so low, and it's this. And this is wired into the volume control. And it's like, I'm going to try bypassing this, jumping red to black. Like maybe this had a remote unit or an auxiliary volume control. Yep. That connector is the reason why the volume's low. Got our chassis hooked back up to the jig here, and keep in mind that the jig has a heater to cathode short on the red emitting element, and I'm trying to work on a solution for that. See, what have we done since we fired it up last? We replaced the color oscillator IC, and we pretty much confirmed that that is running now. We replaced this shorted capacitor here that was causing no audio, added heatsink compound to that IC, you can see it there, bypassed the remote hookup here, so hopefully we have audio. I do have the cathode current connection for the horizontal output tube. So we'll fire it up. I have it hooked up to the VG91 there. If that works and we have color, then I will connect it to a converter box. There was a comment. There's always comments how people love color roundies, as they're called, which are the round tube color sets. Well, you know, those are not as aplenty as the rectangular tube color sets, but they're pretty much the same. The only difference is the besides one picture tube being round and the other being rectangular, is the rectangular chassis has some pincushion correction, but other than that, a lot of them were pretty much the same chassis almost. Of course, when they got to be this late, they were hybrid and solid state. But yeah, don't skip over a rectangular color vacuum tube video just because it's not round. It's the same thing. It's just the aesthetics of being a circle versus being a square. All right, here we go. We're just in preheat mode there. And I believe this is the vacation switch right here. Yeah, so if you didn't want instant on, you would turn that and it would. Of course, there is some debate whether instant on. I'm going to tell a little story here. Check this out. So there's some debate whether instant on kills the CRTs or not. This chassis came out of a TV shop that was pretty much closed in the mid-70s, and there were tons and tons of these TVs in there. And we came across one that was still plugged in, and the instant on was still going from like 1975. It had been on with the instant on had been lit up since 1975, and I saw that it was plugged in and that the filaments were lit, and so I powered it up. I just cold pushed the power switch, and it came up and it had a bright picture, and it lasted about 30 seconds until something shorted and it blew the circuit breaker. And then we tested the CRT and it wasn't that weak. So I don't know if instant on really kills the CRTs or the tubes. That's sort of up for debate. It's such a low, it's such a low voltage. I'm going to power it up here. You can see. And it literally does start conducting real quick. But you can see how much brighter they've gotten. So yeah, I don't know. Anyway, let's see if we get Oh, there we go. We have color now. We have color. We have sound now. Okay, so let's see here. Okay, that's luminance. Back. Where's the there we go. There we go. Oh yeah. Let's do split field here. There we go. I think there's some smearing, but that really could be the long leads of the jig. Let's take a look at, so we already looked at this. We should have 7. 1, 2, 3, 4, 5, 6, 7. Let's take a look at the color. That does not, that looks like we're lacking a little color bandwidth. See how this is striped? This should be striped also. So if your color band pass is low or misadjusted, so that might be the source of the smearing. But yeah, these are the three color. Okay. And then that's a combo. So you notice this should be blue and it's red, but that could very well be well, you can get it blue. Well, I think we're ready to hook this up and watch some TV. We're right at about right 22.5, 23 kilovolts. Oh yeah, we've come a long way, baby, to get where we've gotten today.
Still going down. It's his factory. He gets to do whatever he wants. And now it's only 309, backed by demand, but very limited. Stefano, it is the sweetest thing. I know you've done a couple of other handbag designs, but this one has a very ladylike feel.
My dear, you know that actually
Aş para da should be dumb on there use with Dutch about this for sure.
I can see that everybody fell in love with that. And we just took the iconic beautiful
What kind of car to fuck about Baba?
with all the lace motif. I love the beautiful Fiori Ricani that is allowed to see the finish that is coming from the inside.
Yeah, the smearing is disgusting.
On the flower.
The convergence is also way off on this jig. I mean, look at that. And you see there's no red because it's all the red signal is being pulled, all the red luminance signal is being pulled off to the transformer.
Yes, you get the car shield advantage. That's the power to protect yourself from expensive repair bills. Just call Car Shield before your car breaks down. Here's an example of the Car Shield advantage. This is a car out of warranty, and this car got covered through Car Shield. As you can see, a breakdown could cost you a lot of money.
These auto warranty things are actually the biggest joke. No one ever reads the fine print, and a lot of them, they have like a pretty huge deductible, and then they only pay part of the labor. So if your car needs a transmission, let's say the part is The total bill is $5,000. $3,500 of it is the part. $1,500 of it is the labor. Oh,
You see here. Before your check engine light comes on, you should call CarShield because they help cover your radiator and water pump. With so many parts and systems protected like power windows, backup cameras, power seats, LCD screens, power steering, plus so much more.
so yeah, so if the labor on the transmission is $1,500, you'll have a $500 deductible, and then they'll cover 40% of the labor. So out of a $5,000 job, they end up covering 40% of $1,000. So they pay $400 of $5,000.
Protect yourself against expensive auto repairs and receive emergency roadside assistance with your price lock guarantee.
Such a joke.
And be a part of our live show. Here's our toll-free number. It's 1-866-376-8255. We will not hang up. That was a mistake and an error. We apologize. But free shipping. I'm going to ask the cameras to follow me for a moment. And guys, I want to go to in the back for a moment because we've been talking about what makes this set different. Number one, the number of pieces that you're getting. Look at the number of cooking bodies you're getting. 1, 2, 3, 4, 5, 6, and they're good sizes. By the way, if you like this setup, we have this rack that's available for you. This color, by the way,
Smoke.
is called that turquoise color. It's beautiful. But look down below as I open up the cabinet. This is how your cookware set that you're buying will stack. So although the show like individuality, and like this is kind of the way you unlock that, even if it's not like we all want that, right? But it may not be natural to us.
Again, the reason why the picture is not good, there's several reasons. First of all, there's no red luminance because there's a heater to cathode short. Second, the lead length on the jig, the 5-foot long leads that go between the jig and the chassis create smearing. Number 3, the convergence is really jacked up on this. And this does not have dynamic convergence. It has static convergence. And the static convergence is really jacked up. I never set it up. I really should. And I probably should have degaussed it because it doesn't have degaussing and every time you move it. But yeah, it's really smeary, but you can see it's all working. I'd like to see some greens out of it. We won't really know until we actually have a failure with the main Packard bell. You can see when you get solid colors, so it looks okay, because the color information is fed in on one of the grids. Oh, there we go. So there should be some greens right there, which are not too impressive. I mean, they're green, but they're not like real green. But again, it's hard to tell on a jig. I mean, it's watchable.
It was something that I thought I would never be able to overcome. And then I found Omega Excel, and to wait for someone to help me to do something is incredible. I don't have to think if I can do something. I can just do it. Omega Excel works because it worked for me.
Call now or go to Omega Excel.
Overall, I'm satisfied. This was a fun repair. This was a good diagnostic repair. And now we have a backup chassis for the 98 C18. And this is no different than working on, you know, any other set, just because it's a chassis without a cabinet. I will I'm going to use this to do that CTC 24 combo set. Yeah, I think it's going to have a good picture on a good CRT.